we're going to go ahead and get started. Well, thanks, folks. We got a lot to get through this hour. My name is Chris Neidl, and I'm very pleased to welcome you to today, our first orientation for prospective university teams for the Carbon Gardener Initiative, which you're going to be hearing about today, which is something that's been in the works for, the better part of 2 years. We're going to cover a little bit on the origins. While the purpose of today, again, is I know a lot of folks, some of the people that will be joining today from different universities, I've already spoken to and might have some good background on the program, but others saw the invite and we haven't spoken to. So the purpose today is to answer some sort of key questions for people who might be interested. We'll introduce ourselves in a second, but to kind of let you know, what is it like? What is the Carbon Gardener program? Why are we doing it? And what does it mean to be a carbon gardener? And this will put you in a better position to make a decision about whether or not you want to start a team at your university. So we will go through a presentation that kind of covers all those practical and conceptual details, and then we'll have a little bit of a discussion where people can ask questions using the Q&A panel. And feel free to drop a question in the Q&A panel on the bottom as we go, as we discuss, go through the presentation. If something occurs to you, then we can cover that in the discussion. So what I'll do first is just introduce myself a little bit more briefly, as well as my two co-founders of Carbon Gardener. So I'm Chris Neidl. I'm one of the two co-founders of OpenAir, which I'll give a little bit of background on in just a moment. I've been in the carbon removal space for a bit. I'm in Austin, Texas, and I am also the impact director for a think do tank focused on carbon removal called Rethinking Removals. So with that, I'll pass it over to Deeta.
Hi, everyone. My name is Anandita Chattery. I go by Deeta. I'm currently a transfer sophomore at Cornell University studying environment and sustainability, and I've been involved in this project for 2 years. I think it's really exciting, and I'm super happy to, talk about this with you guys, and I hope you guys enjoy this orientation. Passing it on to Garrett.
Hey, everyone. Garrett Boudinot here. My background's in science, so I'll be talking about the science today. Initially, using carbon chemistry to measure how climate is changing and how climate change is impacting our planet and different ecosystems. And over the past several years, in particular, using those chemistry skills to measure how we can reverse climate change, and how we can understand and modify the carbon cycle to remove carbon dioxide from the atmosphere. So obviously, very passionate about all things rock dust and enhanced weathering. I was a research associate at Cornell University running a research program in enhanced weathering when I first met Chris. Was working with OpenAir, kind of telling folks about enhanced weathering, and this idea of the Carbon Gardener program or project just came out of Chris's mind and some of the science we had talked about. So it's really cool to have seen the progression to now launching and telling you all more about it. Any science related questions, direct them my way. Looking forward to this.
Yeah, absolutely. And just to reiterate that, 2 points as we get into it, and I'll share the actual program for today. But if you do put in the chat again, where you're zooming in from, your name, location, and if you're affiliated with a university institution, it's good for us to know. We know there's people from all over the place that are joining today. And then if you have questions, just use the Q&A panel. And Garrett, if they're particularly sciencey or if you have an immediate answer to it, go ahead and just type in the answer. Otherwise, we'll actually save it for the discussion period. So for today's program, there's kind of a couple of levels here of information we want to share. Again, the idea is to give you a clear picture of what we're trying to do here and how you can be involved, and hopefully give you enough information to decide if you want to actually proceed by joining and forming a Carbon Gardener team at your school. So we're just going to quickly give a little background. We'll cover in some more detail where the origin of the idea for Carbon Gardener and how it progressed to a real project. Then I'm going to kick it over to our science expert, who you just heard from, Garrett, who is just going to give a short encapsulated overview of why rock dust matters. What is it? Why is it as exciting? And that's the underlying reason that has motivated this program. And then we're going to talk a little bit about the kind of unique citizen science-based model that is Carbon Gardener and what are the actual specific goals of it. And then after that, we'll get into some more practical details for you that gives you a bit of a picture of what is it? What kind of equipment do you need? What does it mean to start a team? And what is the actual work of carbon gardening? So we'll describe that in a little bit of detail. And then after that, we'll have a discussion. So I'll go ahead and jump right into it. And we'll start again with the origin story, which is a cool one that Garrett gave a little sneak peek at. But just a bit about OpenAir, for those of you who aren't familiar with it, we started almost 5 years ago, which is blows my mind. Myself and another person founded it. And the idea was to create a volunteer network of people that could come in and volunteer their time to advance carbon removal as a climate solution in various different ways. And today we have hundreds of members all over the world working on different projects that we call missions. So some people are trying to pass laws in certain places. Other people are building cool things like open source direct air capture machines. And Carbon Gardener is a mission of OpenAir that came out of it. So it's one particular thing that we do. We're not a nonprofit. We're not even an organization. We're just a network of people that connect on Discord. And I'll share some links before we end if you want to join it. And the way that it happened that Garrett mentioned, just to give you the story, this is going back a long time now, over a couple of years ago, right at the beginning, OpenAir has a weekly show that we do called This is CDR, which is interviews with different carbon removal entrepreneurs or experts. And we're now up to episode, I think, 85. And Garrett was our second guest. And he came on and he started talking about his research at Cornell, where he was at the time. And it just kind of blew our minds. And particularly when he talked about it, I thought, well, what he's talking about some of the challenges of rock dust / enhanced rock weathering, I think would be a good fit for a citizen science initiative where you can involve a lot of people to help fill in some information that's one of the biggest barriers for it, which Garrett will talk about shortly. And so from that, we jumped on a call almost immediately after. And then we met up over coffee and lunch in Glasgow during the climate conference there back in November 2021. And almost on a napkin, we sort of hashed out an idea here for what a citizen science program might look like to help solve some problems related to data gaps for carbon removal, or rather for enhanced rock weathering. And that's really where it started. And we kind of got going from there. And even before that, Dita was already a member of OpenAir, working on advocacy for a bill in New York City, where she lived when she was just in high school. And she had a real interest in this. I said, I got to get Dita involved with it. So Dita jumped in relatively early, and we started to think through this a little bit more about what are our needs. And then we were fortunate to find out about a grant program started by a small philanthropy called Drawdown, where they wanted to fund carbon removal research projects that had a sort of an open source citizen science angle to it. And so we wrote a proposal for that, and we got that grant. And that's actually what helped us with our setup cost. We're all volunteers here. There's no actual staff. But we did have some costs for our website and some other things that we needed to do. And once we got that, we kicked into gear to actually build this program. And over a period of the next several months, quite a while, we developed our protocols, our methods, our scope, and then created our website, which is an important tool that you'll hear about. And we did this with some help from some other volunteers as well. Josh Perfetto and Lucia Simonelli both jumped in and made valuable contributions and are still part of the team as well. So that is the story of it. And that got us basically into the summer when we launched our website. And now we're in recruitment mode. We want to get universities involved in the program, because it will be very much driven by universities and in some cases by other institutions and even high schools. And so what I'll do right now, just to refresh people's memory, if you're or not even, just introduce you to rock dust real quick about why do we even care about this? And I'll hand it over to Garrett, who'll give us a little quick synopsis.
Great. Thanks, Chris. So yeah, the name enhanced rock weathering is itself kind of jargon. So we're going to walk through why we call it that and why it matters for removing carbon from the atmosphere. When we think about kind of global scale carbon cycling, one of the big levers, one of the big transitions for carbon from the atmosphere into water or into the subsurface is through the weathering of rocks. Is interesting because we think of carbon as an organic element or an element in organic molecules, but actually inorganic carbon, this weathering of just silicate rocks on continents, is actually a huge driver of the drawdown naturally of carbon dioxide from the atmosphere. And the way this works is essentially CO2 is in the atmosphere. It mixes with water that's in the atmosphere to form carbonic acid that rains down. And it interacts with the chemistry of certain types of rocks to drive a chemical reaction that essentially converts that carbonic acid, CO2, that was a greenhouse gas, into stable carbon molecules like bicarbonate and carbonate. So we'll talk about that a little bit more. Next slide. And so we figured we could enhance the rate of that reaction, the rate of that rock weathering reaction through a number of processes. But really, when you look at where we want to do that, soils turned out to be a great place to deploy that. And so when we talk about enhanced rock weathering, we're talking about enhancing that natural reaction between rocks and carbonic acid or CO2 in the atmosphere to draw down carbon into stable carbon molecules. Next slide. So I keep saying rocks, we're talking about actually a very specific kind of rock. So they're made up of mostly silica and oxygen. These are just inert elements in the mantle, but then they have a certain amount of magnesium or calcium. And what's special about these rocks that have magnesium or calcium is that when they dissolve under the influence of carbonic acid, they release that magnesium or calcium. Those elements have a 2+ positive charge, which means when they go into water, now they have positive charge that changes the chemistry of that water. We can go to the next slide. And so that silicate magnesium and calcium rich rock weathers naturally. We can enhance the rate of that reaction by grinding it up into what we call rock dust. It's as it sounds, powdered or dust form of that silicate rock. Actually, what we work with is often even more fine grained than what you see in that picture. It's truly dust, and the reason we do that is, again, we can enhance that reaction rate because it's carbonic acid in water that's weathering the surface of those grains. Smaller grains, more surface area, we get a faster reaction.
And I knew you'd bring that up, Garrett. I'm sorry I didn't have one a little more fine grained, but yeah, it's more of a dust.
That's all right.
Chunks, so
yeah. So I think this is a video. Is that right?
This is just to show when you apply it to soil, that's
Cool.
That's when it happens. And then when we get into here is more the chemistry part.
Great. So as I said, so rainwater has carbonic acid. Soils also have a lot of carbonic acid because anywhere that there's a lot of CO2, which in soils due to respiration of soil organic matter also generates a lot of carbonic acid when it's mixed with water. And as I said, that carbonic acid mixes with the magnesium and calcium in those rocks specifically. I think it's the next slide there. To form this bicarbonate. And I mentioned the charge. So bicarbonate is a -1 charge as a molecule. Magnesium and calcium is a +2 charge. Sorry to get into the chemistry for those of you who don't think about this all the time. But essentially what that means is that we can sequester 2 molecules of carbon dioxide because of the charge balance for every 1 molecule of magnesium or calcium. And that means that this can actually be a pretty rapid carbon dioxide removal technology when we just spread it in soils and let it do its thing, mix naturally with the CO2 that's in soils and the atmosphere, dissolve, and create bicarbonate that stays in water. Now, that charge balance that I talked about, that's actually a pH change as well. And so what this also does is decreases a pretty big problem for a lot of the globe's food production and soil health, and that's acidification. And so folks actually for many years, even centuries, have been applying magnesium and calcium rich rocks into soils to decrease acidification. Here we kind of call that a co-benefit. Our main focus for particularly this project is thinking about the carbon removal, but it also improves the soil health with acidification. There's some other potential co-benefits as well. So in a lot of acidic soils, heavy metal toxicity is a real problem. And so by buffering the pH, we can reduce a lot of that heavy metal toxicity. And then there's some other actual evidence of improved yield from certain crops because of the other nutrients, micronutrients that are in some of these rocks, things like phosphorus and potassium, and also, again, the way that the soil behaves with less acidification and more or higher pH.
Great. Thanks, Garrett. And I'll have you even add a little more commentary on this, which you certainly have. But to again, what Garrett just spelled out is how this works. But you want to, when you think about it as a carbon removal or a climate solution, it matters is like how big of an impact could it potentially have? So like, why is this worth doing? And there's many different sources of data that we could draw on that try to quantify this. One really good one that Oxford University and the University of Wisconsin at Madison put out earlier this year, the State of CDR report, quantified different forms of carbon removal in different types of metrics. And so with enhanced rock weather, and one thing that's really significant is the billions of tons per year that could potentially be achieved through that, on the outer boundary of this, which is, somewhat of a conservative estimate, is 4 gigatons per year. And so the UN International Panel on Climate Change estimates that by the middle of the century, we need to be removing about 10 gigatons per year and then 20 after. So that is not the entire amount, but that's a significant amount if we could actually really get this going at scale. The other thing too is that potentially on the lower bound of it could be quite cost competitive compared to a lot of different forms of carbon removal. And here I'm just showing 4, and there's many more. But if we get it down to that $50 per ton mark, that makes it financially scalable. Now, the part that's really important that really is Carbon Gardener is really sort of rooted in is this thing which they call TRL, which is the technology readiness level. And that's a 1 to 10 score that basically estimates how ready is this to actually be used in some sort of scalable way. And right now it's about a 3 or 4. And as what Garrett just described you, it doesn't sound like that technologically significant, right? It's grinding up a certain kind of rock and then using existing agricultural equipment to spread it out as dust. So that doesn't seem exactly like, fusion. But the real reason why it has a low TRL has to do with both how do we monitor that is actually happening, but even more fundamentally, how well do we know that it actually works in lots of different types of context? And there's big data gaps that we just don't know how well it works under different circumstances. And that really is the sort of motivation behind Carbon Gardeners to try to help solve that problem. And Garrett, I don't know if you had anything else to even talk about that, about what we know and we don't know, but there's obviously a lot of soil, environmental, and climate diversity that we can presume there'll be different results of rock dust in each one.
Yeah, I mean, I'll just add, you hit the nail on the head. I mean, chemically it makes sense on paper, but as we know, the climate and environments do not behave as kind of chemical equations behave on paper. And so we really need to know how this behaves in different environments. The very few studies that have been done actually testing this have shown a wide range of variability. And so there's likely trends out there that we can identify to optimize this, to measure it better, but we really need to generate more data.
Excellent. And this is where we think that citizen science in a project like Carbon Gardener can fill a real role. So to cover the model, I'll do a little bit of this, and then I'm going to pass it off to Dita at the last part of this section. But again, citizen science, which some of you may have participated in, is a way of utilizing people all over the place to help fill in data gaps or to run experiments in ways that any given lab or series of labs couldn't do by themselves. So it's an important emerging paradigm for research, and we think it's a really, really good fit for this particular problem. And some of you might, the one that I used all the time, there's literally hundreds of different citizen science projects, but Zooniverse, but eBird is one that also came out of Cornell, where it's monitoring bird sightings of populations. And it's actually an incredibly important resource for ornithology research, particularly global populations of birds in the world. And it's something that really could only be done through citizen science. So it's not just cute, it's something that actually is really science. And so we want to play a similar goal here. And as we just said, we want to say, can we add more data to show how carbon or enhanced rock weathering works in different types of settings? But as a kind of a knock-on effect to that, but if we're doing this in many different places, can we also build general awareness and excitement, not just among students? We love the idea of students like really being passionate about this and potentially pursuing it, in some type of way in their studies or even professionally. And where they are, can they help raise awareness about this is a potential solution. And when you add all those together, can we have a net effect of accelerating progress on carbon removal? So those are really our goals. And how do we do that? And the idea is, and this is why we think it's a really good fit for citizen science, because you can get that data from a lot of different places with relatively little constrained resources. So very little amount of soil or land. In this case, as we'll show later, we're talking about raised beds, which you can see there on the right screen. That could be a little testing area. And each one that we do will have a specific environmental context with different factors that can give different kinds of data. And if we do testing there by applying rock dust in those test beds and then monitor and sample, that can give us rich data for that particular data point, which is amazing. But to make this really be beneficial and useful from a data, from closing data gaps, we want to do this all over the place. We want to sample the world. We want to have these types of test pits all over the world in as many different settings as possible and have it spread almost virally. So that is the main objective of the Carbon Gardener project. And I'm going to pass it over to Dita, who will explain why we think universities are really ideal partners to really drive this. So go ahead and take it away, Dita.
Yeah, sure. Yeah, I think I'm like the perfect person to speak on this just because I'm in university right now. But I really do think that university teams would be the perfect way to incorporate this into Citizen Science Project, just because we do have the space, the interest, the skills, the resources, and the ubiquity. We have the funding, we have curious, smart students who want to learn more and want to contribute to bridging that data gap. Next slide. So I just want to talk quickly about like the process of what it would look like to go to form a team, to go from the university team to, completing the project. You'd start by forming a team. So this would be maybe, I'd say 4 to 5 people at your team. And then you'd start building a bed. You choose you choose a bed site and you build a small test garden on your campus. And then we'd go into testing the soil, which would be applying the rock dust to the beds and conducting regular tests. So this would be maybe like twice a week, once a week. And it doesn't have to be every other week because this is such a long project. It does allow for a lax in, we don't have to do this every single week. And then moving on, we could go into reporting the data, which would be the final step. We have our website open, and all of these citizen science teams would be logged on there and reporting the data as they go on the Carbon Gardener platform, from which everyone could access it because it's open source data. And hopefully we could get this published at the end of the year.
Oh yeah, that's an important point. Like we do this and we'll share it with the world, both on the website, and then we will actually try to publish the data in a way that can actually have a real influence.
It's just a great way for university teams and students to get involved. And moving on to the supplies and setup, we can talk about how if you go to our website right now, this would be one of the first links you'd see. It's all of the supplies you'd need to conduct this experiment, either on your own or with your university team. Complete transparency, transparency, literally everything we'd be using, why we'd be using it, the notes on the function, and a sample product, like a link to what we'd be using or what we or like a standard product that you could buy, as well as the price ranges for the products. So there's for this testing, you're going to need some common tools and materials, like the hoe, the shovel, the tape measure. All of these things you could find at Home Depot or Lowe's. It's very easy to locally source these. And then we'd get the fine basalt rock dust. We'd help you select a buyer to get this rock dust from. And I think Garrett can speak more to what type of rock dust we'd be using and how we would source these for the for the university teams.
Yeah, I can speak on that just very briefly. Again, there's lots of different types of rocks that have magnesium and calcium and silica. One of the most ubiquitous rock types on the surface of the planet is a rock called basalt. It's got about 20% calcium and magnesium, mostly silica. There's no appreciable amount of heavy metals or anything that we wouldn't want to add to soil. So it's a great candidate. And actually, a number of existing mining operations generate pulverized basalt as just a byproduct of what they're mining for aggregates, for construction, for infrastructure, for transportation. And so we've identified a number of suppliers that are really distributed around the US. For international folks, we'll help figure that out, where we can get a pretty homogeneous or similar testing material for all of our teams to use. That also is really quite relevant for this once it's at scale, because basalt is really the most abundant for this type of application.
Awesome. Thank you, Garrett. And then for kind of as a requirement to join as a university team, most universities should have a lysimeter and a pump. These are used to measure evapotranspiration and do concentration analyses. But if you don't have these, we can help you work around it and find different ways to source it. And we also have the total organic carbon analyzer, the TOC, which would be really important for this project. And this is also something we'd expect university teams to have. And Garrett can also speak a little bit on why the total organic carbon analyzer is so important.
Yeah, so the part of the data gap is that we're trying to correct here is that the world hasn't been studying enhanced rock weathering for carbon removal for very long. The other side is it's very hard to measure enhanced rock weathering's effect because, again, this is largely a water-based reaction in soil. And so measuring carbon that's in water, that's in soil is just difficult to do traditionally, which is why we need things like a lysimeter to pull the water out of the soil, as Dita just said. And then the other side is we need some analytical technique to measure not just CO2 in the water, but also bicarbonate, because that's really the reaction that we want to trace is not just changes in CO2, but that we're also producing bicarbonate. There's several analytical techniques or technologies that can be used to make that measurement. There's some that are very labor intensive, like a titration, which for those of you who have done kind of chemistry 101 at a university level, you might have done in a lab there. Takes a long time, but you get pretty good data. And then others are more automated, like a total organic carbon analyzer that we're showing here. Now, part of the total organic carbon analysis that is automated in these types of instruments is also a process that analyzes the inorganic carbon. And that's what we are looking for. There are some other technologies out there as well. We're presenting total organic carbon analyzers here because we know that that is a pretty common instrument across universities. However, if you don't have one at your school or organization, let us know. There's almost certainly the right analytical instrument somewhere in your area that we can connect you with to do the sample analysis component of this project.
Excellent, thanks.
Yeah, and then the last thing you'd need is the raised beds. These are just some pictures of me at the Brooklyn Community Garden. Shout out the Brooklyn Community Garden. They're awesome. It's an amazing place to be. And this is a sample bed that we created there to show you guys what it would look like. This is just me shoveling shoveling soil into the rock bed and then dividing it in two, and putting flags and markers for what soil we're testing. You need 3 raised beds for this setup. And you'd have to, and this is what it would look like, sort of. You divide each bed into 2 different sections, the control section, which would have no rock dust, and then the treatment section, which would have the rock dust basalt sprinkled over it. And afterwards, you'd plant some sort of easy to grow crop like lettuce on top, and you'd use the lysimeter and the total organic carbon analyzer to measure your samples afterwards, and then just send them off into the website so everyone can see your data.
Excellent. Great. Thanks, Nita. And I saw that we did have a hand up. If folks want to just throw any questions they have in the Q&A, we'll go ahead and address them that way. Okay, great. So now just in terms of the practicalities of actually getting a team going, what does that mean to be a team? So we'll get into that, and then we'll talk a little bit about what does that testing actually looks like? And then we'll wrap up with the presentation, and then we can take folks' questions. So in terms of starting a team, there's some basic requirements here, as you may have already, kind of picked up on. It's not a particularly labor-intensive initiative to participate in, but it does require a certain commitment of time and consistency in our testing. So it's helpful to have, whether we call it a captain or not, but somebody who really initiates the project and registers the team, and their email is the main point of contact for logging into the platform. That's the best way to do it, which we'll show you in a second. If you're at a university or school, it's definitely very helpful to, whether it's a faculty advisor or somebody in the university who can ensure, as we've already seen with those who've already signed up, that can help with, all right, well, where can we put it? Does it go in the university garden? Is there some particular place in the university where it makes sense? They can open up those doors, as well as access to equipment, and also some of the expertise that they have around the testing. And then, one sample per week or every other week, with an understanding that, vacations come up and people are off. But in general, the more regular we can, as close to once per week, is ideal for going and doing those lysimeter tests. And the membership is really quite wide open. It depends, but we think just to divide the labor, where some people might be, all right, this week I'll do it, next week somebody else will do it. It's helpful to have, upwards of 5, or if there's a lot of interest, you can have more people. And that also helps in a university too, where you might have, certain people drop out, or somebody was there for one semester and then they've graduated. So it's good to have, at least a handful of people to ensure continuity. And it's certainly great for people that are science students, like Dita, to be part of this project. But it's a relatively simple thing to actually do, that if somebody's an English or a philosophy major or something like that, they can also participate. So just to be clear, it doesn't really require a hard science, to be a member of a Carbon Gardener team. And what happens is if you're interested, after this orientation, I'm going to edit this video so that you have it, and I'm going to send an email to everybody who RSVP'd, and that will include a recording of this, but it'll also have a form that you can log on to register. So if this is something you want to do, then you would register, and you'll need a little bit of time to sort of think this through, but that will be the link where you do it. And if you register, then you become a team on the website, and there's a little bit of information that you have to fill in, as well as some background information, just some kind of metadata about your site, like average rainfall, and snowfall, which is incredibly easy to get from different sources. And you can edit that at any time. This also gives you the opportunity to add who the members of your team, just the name, age, and major. That's just for us to know. And you can change that at any time once you've registered and created a profile. And then once you do that, you also pop up on the map. And that's just a way for us to see, well, where are all the things happening? And there's a little progress bar that if someone's in testing, they're further along. And if they're done, it shows a certain thing. But it's great for us to get kind of a global view of where all the projects are happening. So that happens with registration. And then the really important thing that happens is once you've registered, then you have a login ability on the top. And that means when you press that report data, that brings you to our dashboard. And the dashboard does a couple of things that are really important. First, it gives you the sort of the training and the resources to do through all the setup. So you can see it's based on sort of 5 stages, right? So there's the kind of basic setup, start your team. Here's a checklist for your supplies. You can see, okay, I got all those supplies. You can advance to the next stage. This helps you with the bed preparation in detail, some videos we've created as well. And then the main place where you're going to hang out, though, for most of this is in the sampling and reporting protocol area. And that is right here. That's stage 4. That's really where the year is. And this is where it both gives you instruction on how to do that, but it's where you actually log your data. And so I'll just give you a little bit of a view of that. Again, it includes instructions, and we're even tweaking and adding some more as we go. And I'll mention in a few minutes that we also have a forum. So it's not that you just have to look at this and then you're on your own. But if you have any questions about any aspect of this, you can ask a question in the forum, and me, Dita, and Garrett will be on there. But as more students are on there and other people, a lot of us will be able to answer those questions. So there'll be a lot of hand-holding and guidance as we go. And what this includes is some information on how to do the lysimeter sampling, but then also where to log the data once you've done that. And this is a thing that Dina showed you before, but you'll have lysimeters in each section of both the control and the treated beds. And then the types of data that you're actually reporting on are both a water analysis and soil test. And this is a screenshot right from the platform, and it shows you how many different types of tests you have to do. You have to do 2 water analyses and then several different soil tests. And when you click on those, they actually give you the types of information that you're getting, which I'll allow both Dita and Garrett. Maybe I'll pause there right now. Garrett and or Dita, if you want to just talk about what kind of information are we actually collecting with the water analysis and how?
Yeah, I'll jump in just real quick. So, as Chris said, all of the templates there for all the data that we're looking for, it's just something you can fill in. Obviously, because we want to understand how geography and climate impacts this reaction, there's some kind of location, bed size, all of that, just to kind of be able to standardize the results. And then we're getting a number of standard carbon measurements from that soil water that come with those analyses. So TIC is total inorganic carbon. That's something that any of these analyses will give us. We also want to know things like how much water you collected and sampled. pH, again, because this is a pH mediated reaction, and then the concentration of those different carbon molecules. And once we have all that, and again, from all these different locations, we can really have what will soon be the world's largest data set showing how this reaction plays out quantitatively with what should be a pretty simple analysis. And then I'll just add on if you want me to just add on the soil side, because soils are all different in the raised bed construction, we have some guidelines on what types of soils to mix in with the basalt, but we do want to normalize some key chemical components of the soil to, again, these other carbon cycle measurements that we're making. So the main ones are things like total carbon, total organic carbon, major elements like nitrogen, also the existing calcium and magnesium of the soil. These are all things that you can get from a local extension office. So the cooperative extensions in the US do pretty low cost, standardized soil analyses. And then there are non-extension offices here in the US and abroad that also do these because agriculture requires a lot of these measurements for improvement. So we're happy to guide folks on where to send samples here to be able to, again, compare the results we're getting from the carbon in the soil water, normalize those to variability in soil.
Yeah, and real quick, Garrett, just to give people a sense of what this testing is. Test tubes are on the supply list. It's a relatively simple test, both on the water and soil, using the lysimeter water. I don't know if you just, in a moment, just want to sort of sketch out what the nature of those tests are, so people have a sense of what they'll be doing.
Totally. Yeah, that's a critical component here. So the lysimeters allow us to sample soil water. And Dita mentioned there's a lysimeter and then there's a pump. So the lysimeter collects soil water by creating a vacuum that sucks water into the lysimeter, and then you can pull it out. So we'll install lysimeters, create vacuum about once a week or however frequently the samples will be collected. Give it time to bring water in from the soil, which is a couple days, and then collect that water from the lysimeter, put it into a test tube. You can save those in the fridge for a while. And so then with some regularity, maybe every month or so, then put that into the either the total organic carbon analyzer, the dissolved inorganic carbon analyzer, the titrator, whatever technique we end up, or each team ends up using. And that's going to happen throughout the project. The soil test really only needs to happen a couple times. It needs to happen at the beginning when we know, like, what's the chemistry of the soil before we add any rock dust, and right at the beginning before any carbon cycle changes have occurred. And then at the end. And there there's a very simple protocol. You take a trowel, take a few inches of soil from the top, put it in a bag. Some offices or some labs want you to dry that soil for a few days. and then ship it off.
Great. And one thing I should mention very importantly is that all of these things together is relatively low cost, and we put an estimate for that. We have some funding support for the first teams that join for this. So if you do register, we can kind of talk through what do you already have and what don't you have, and do you need some funding support to get going on this? And then after that, as we grow, we've discovered that a lot of universities, particularly university clubs or departments, it's under $1,000 total if you had nothing, you had no shovels, no anything like that. But there's ways that we can also help with funding for that through crowdfunding, for instance. And a lot of times those programs will have some funding available for these types of student projects, but we can work with you to make sure that this is something that is economically affordable for you. This is just a look at, this is right from a screen capture of, when you do a soil test that you enter that information in and you add submit, and then it gives you a nice, over time, a table that shows you the results of those. And the same thing for the water test as well. So it's very easy to add and then to edit if you made a mistake as well. So just the final thing here, and then we'll take some questions for people. We can actually, if you want to say it out loud, we can make you a panelist. We could talk through it, but hopefully this is giving you a good sense. But in terms of tools and timeline, one thing that I did mention is that we have a forum that we started for this. So if you do register, we'll give you an invite to this, and we'll be posting stuff on there. But this is like where the nitty-gritty details. You're like, well, I have this lysimeter. Is this good enough? This would be where you'd ask it, and we'd answer that. You'd be like, well, my bed is a little smaller than this or whatever. Those kinds of questions that you have is where you can ask those and get answers, okay? And they basically map onto the different parts of the project. And as the community grows, more and more people will have answers or will have already asked the same question that you might have coming in as a new member. So this is the real benefit of a citizen science sort of crowd-based project. So that will be very, very useful. And then in terms of timeline, as I've said, I'm going to send out that email as soon as I have the video edited. So you'll get it in your inbox this weekend. That will include our contact information for the project. So if you have very specific projects that weren't answered here that you want to know, you can ask them directly to us. It'll have that registration link again, if you want to set up a team. It will give a invite to that forum, which you can then be on, and then you'll be able to see other people's questions and answers or ask your own. And then it'll have a recording of this session that we're doing today. And then if you're really serious about it, we have a couple of schools. UT Austin, where I'm based, is definitely doing one. And we have a couple other that are really close to confirmation. There's some work here about finding about equipment and doing orders and stuff like that. But at the fastest, we're talking about the beginning of next month. But the way we'll do it is it's just going to be done on a rolling basis. We need 12 months commitment, but if you start in February, that means it's February to February. So people can go ahead and join whenever they're ready to do it. And then what we want to do as well is just Dita is going to be doing interviews with carbon rock dust experts and entrepreneurs on Instagram. And we'll be sharing on her Instagram her own experience doing her own carbon gardening at Cornell. And that's useful information for people who really want to geek out on the subject. But we'll also do little check-ins if people want to jump in and actually talk to us live or to other people and join. In addition to the forum, we'll provide that on a monthly basis. So that is the end of our presentation. We do have a little bit of time to take people's questions over the next 15 minutes. Don't be shy, or comments. If anybody has any sort of ideas or thoughts, don't be shy, and feel free to go ahead and ask questions. And if you don't want to, that's okay. You'll get that email tomorrow, and you can ask them to us directly by email. So if you have a question, just go ahead and raise your hand or pop it into the Q&A. And we won't be offended if you don't have questions, but I think you probably do. All right. I think we'll give that another minute, but maybe we had a very complete orientation there. Here we go. We got Huan Sheng. Huan Sheng, let me go ahead and you can ask that question directly. I'm just going to make you a panelist. So you should be able to turn on your microphone actually and go ahead and ask. I hope that works. Looks like you are. Yeah.
You guys hear me okay? So yeah, so the question is, so for the plans, it's going to be the same like for all the groups who join the project, or and will you guys send out seeds or like or the sequence or whatever? How that thing? How do we get the plans?
Garrett, you want to take that one? We have some flexibility there. It's not even, we even debated about whether or not we would require plans, but we think it is a good thing to add because it could actually show differences in impact. But go ahead, Garrett, and you have anything to say on that?
Yeah, our decision was to include plants because again, the source of CO2 for this reaction in most soils is going to be from respiration of root matter from plants. We we are flexible there. I like things like lettuce where the seeds can just be spread, or any leafy green where the seeds can be spread. It can germinate right on the soil. It doesn't have to be transplanted. It grows pretty quickly. So that's, our plan here, but generally flexible. We don't need to source the same seeds. As long as there's roots in there that aren't at a completely different depth, that's the goal here.
And those are cheap and can be bought at any gardening store, so that's a relatively easy thing to procure locally. Does that answer your question?
Right. Yeah. Thank you, guys.
Great. Any other questions from folks? Okay, so one thing I do want to just really stress is that it's not, you're on your own now. This is just the beginning to try to hopefully give you a more complete picture of what is entailed with this project. So when we send those emails and when there's registration there, that's where on any particular point along the way, whether it's a question about, equipment use or how do you procure this, or I'm not quite sure on this testing matter, or am I in a good place to do this? That is where those specific questions will be answered to help you along the way. So this is, again, just to kind of orient you more generally. So as you do have those questions and as you think these through, we'll have the answers for them and we'll talk through them. And again, you'll see that email and that's your opportunity to talk back to us, either ask questions or to register, and then we can take it from there. So it doesn't look like there's any other questions, and I'm happy to give you guys 10 minutes back. But really appreciate everyone's interest. We're going to start hopefully at UT Austin quite soon. I see Sophia's here. That's my hometown, so I'll be involved in that myself, and Dita as well. And so there'll be a couple of projects that are already starting. We'll be sharing what we did, taking pictures, putting it on the forum, putting it on Instagram to, again, give you a more specific sense of how this actually works in the real world. And yeah, so we really do hope. We're really excited about it. We got Boston, we got Kenya. Hi, Sarah. We got Austin, we got Hull. We got a lot of people just in this small group, Duke in China. So it would be amazing if we had, right out of the get-go, a global spread. And again, we do have some resources to help this first cohort out in terms of handling costs as well. That came with our generous grant from Drawdow. So we can talk through all those issues, but we don't want costs to be a barrier for people as well. So with that, Dita or Garrett, any final words of enthusiasm or guidance to offer before we sign out?
I'm just so excited for every team that's going to be joining, and I think it's just going to be a great year filled with amazing, fun research, and it's just going to be a great experience for every student involved. And I can't wait to help bridge the gap for enhanced rock weathering research.
Great. And we did actually just get a question from Sally, who I think is at Hull University, that Garrett, maybe in your sign off, you're probably the best person to answer that. But it's, if the CO2, which will be taken up, is from root respiration, then is there a CO2 drawdown from the atmosphere directly?
Yeah, and I put my response in the Q&A, but that's a great question, Sally. And the idea here is plants are kind of the conduit for CO2 going from the atmosphere into soil without rock dust. Under normal conditions, once that organic carbon is in soil, it's then respired and put back out into the atmosphere. So the rock dust is able to essentially capture that CO2 that's in the soil that's been brought in by plants, convert it to bicarbonate where it's stored rather than releasing it. So yeah, soils or plants are kind of a helpful component here. And yeah, so that question, is it only effective if there are plants? it's likely that it is most effective when plants are there. And then we think about, but certainly not only. I think there's likely many soils where organic carbon is being respired in the absence of plants, or B, where this could happen passively, just from carbonic acid and rainwater. So we're really going for what's more effective. I think the other side of this is, where is this going to be deployed? Likely it's going to be agricultural soils, as you know, Chris showed that picture of a tractor spreading rock dust. That's where we already have the infrastructure to do this. Folks are already adding amendments to soils for agriculture where they're growing plants. And so that's really our main target here. Those are all great questions.
Excellent. And I see we also had a question from, the other thing I should say too is on the Carbon Gardener website, which you may have already seen, if you go to the resources page, I think it's resources or learn, I don't have it in front of me. We have videos for all levels of learning, including Garrett's original This is CDR presentation, but then other things from the media as well as academic, and then a really good fact that our volunteer Lucia put together. So there's a lot of good information to take a deeper dive into the science of this as well as the operational aspects. So please do take a look at that. We do have a question from Robert. Robert, how are you? You should be able, it looks like you're on mute. So if you just unmute yourself, you should be able to talk.
Hi, yes, sorry, I accidentally raised my hand, so I don't have a question.
No problem. Okay, great. Yeah. All right, sounds good. So keep an eye out, look in your spam boxes if you don't see it by Saturday in your inbox, but I'll be editing this thing early tomorrow morning and then shooting it out by no later than early Saturday. So we do hope to hear from some of you folks, and would love to, who we're looking at right now on the chat is our initial cohort of Carbon Gardeners worldwide. So thank you everybody for joining, and hope to talk to some of you soon. Thanks.